Hello and welcome to Process Control Made Easy, and today we're going to explore part 3 of our linear 7th axis for robots. We're going to focus on axis motion control, and to do that we're going to use again our PC and a Galil Motion controller. And we'll be going through the Java code and the Galil Motion Control code. I think you'll find that it's very straightforward. So as a review, let's take a look at what we have, which is our PC controller connected by Ethernet to the Galil Motion controller. And we're issuing from the PC the move instructions pretty much as a text file, even though we will build those move instructions using the Galil design kit and the editor there. Then the Galil Motion Controller, once it's running, will be sending back position information and the digital I/O status, which Java will use to create the overall environment and layout of our axis. So in Java, we'll be using the Galil Java wrapper to achieve that control. So with that, let's jump into the Galil code. Now, the Galil code is going to look perhaps a little bit strange, and we'll explain this. Every instance of a command is pretty much a capitalized two-letter word. So let's start out with the top, which is the program name, and it's always preceded by a pound sign and then lowercase what the name of the program is. Then we, on line 2 here, we have an interrupt for digital input number 4, and it's really looking for a state change there to say, yes, I've changed, go do something. Next, we have our subroutine identifier, which again is preceded by a pound sign and a lowercase value. And then we're going to use an if statement. Now we're going to go look for the left or the forward limit switch. And in the state of 1, you'll see on line 5, if LF underscore LFA, which is left forward limit switch of axis A equals 1, which means it's not triggered, then we're going to jump to routine number B. If it is, then we are going to go into routine number C. So again, if the forward limit switch is not engaged, call subroutine B. If it is, call subroutine C. Next, as we go into B, we're actually going to create motion here. The very first thing we have to do is identify the type of motor we're using. And in Galil code, the MT, which is motor type, and -2 signifies a stepper motor. Then we have to turn that motor on, enable the motor. So we issue the SHA command, which is servo here axis A, and it again turns the motor on. Then we set the acceleration, which is ACA, and the deceleration. Now the values here are in pulse values, okay, and DCA is pulse. These are pulses per second. And here's the jog. Now jog will move the A axis until motion has been stopped by either the interrupt or a limit switch. And the value, if it's positive, it moves forward. If it is negative, it will move in reverse. Then we have to start the action. So we've given the controller all of the information it needs to execute an action. Now we have to tell it to run that action. Now we want to wait on the controller until it's completed its action, so we issue the command MC. And once the motion is complete, then we will jump down here into our subroutine C, and we're going to creep backwards by 2,000 pulses. And if you're familiar with the stepper motor, you'll know that's not a lot. But essentially what we're doing is we move to the limit switch, we have a little bit of over travel, so we want to come back and then we're going to establish that as the position. So all of this then gets written into Java as a text file, and or it gets written as a text file, and then we use Java to transfer that text file back to the controller when we're ready. So I think you will find that the Galil Motion Control programs are, once you get the hang of it and you understand what the language is, and by the way, they've got absolutely wonderful manuals that will help you understand this. And their customer support, unbelievable. So let's jump into Java then. And I know this is a little bit quick, and this may look a little strange, but this is our calibration program. Now, I'm not showing you all of the code here because it's rather lengthy, but I want to go through the base components of this. First of all, this is our calibrate axis method. So this is the method that we're calling to actually run the calibration. Next up, we have to instantiate the Galil wrapper, so we call it here on line 30. And then we're going to read the controller IP address from the text file. If you remember back where we wrote the text files with the IP address in our configuration files, we're picking those back up, and then we're again replacing the commas with a dot so that we have it as an IP address. Then we want to create a socket to the Galil controller, so we do that here on line 53 with a gclib .gopen, and here's our IP address, IIPR, and so this is our direct communication. Then we want to download the program. We're going to sleep this for about 100 milliseconds just to give the controller time to respond. And then we're going to download the program. Next, we will execute the program because we've created the program on our previous page, and we're now going to, we've downloaded it. We send the execution command, and then we want to let it sleep for a little bit. So we're going to have another 100 milliseconds of sleep. Then we run a for loop. And essentially what the for loop here is it's just measuring, it's reading the feedback from the controller under this G command, which is mg _ xq, which is execute, and 0. And it's looking for a return value of -1. So once it reaches -1, because it's a countdown, it hits 0, which means it's basically stopped, and then goes to -1. So Java is listening for that return of -1, and when it gets it, it breaks out of the for loop, and then we sleep the controller for about a half a second, 500 milliseconds. And the reason for that is that we want to ensure that the controller is completely at rest so that we know exactly where it is, and then we pick that position up. We request the position here on line 68, which is the mg _ RPA, which is relative position of axis A. Then we bring that back in, we split the string, and what we're going to do is, this is taking the white space, this line 69 removes the trailing zeros and the decimal point, so now we've got basically an integer. And then we need to remove any white space that is in front, and so we have got our integer. Then finally, what we want to do is we want to close the socket to the Galil controller. I know this was fast. This is the basics of both the Galil controller and the Java program. If you have any questions, feel free to send me an email. If you'd like the code, I will send you an email on that. I'm going to try to get that up on the code for all of these snippets onto the ReefWorks website in the coming days. So if you would rather go to the website and take a look at it, You may have to wait a little bit until I get that done. Again, thanks for watching, and in our next video, we will begin to explore the socket to the robot. Thanks, and we'll see you in our next video.